So in this brief video, we're going to go through sketching regions on complex, or sketching subsets of the complex plane. And this is a very standard exam 2 question. So I'm not going to speak over anyone. So just quickly, we have this, and it says write in Cartesian form. This is a really common thing where you have to write in Cartesian form. Sometimes you might have to show that a certain thing. But in this case, if you don't get the Cartesian form, you're going to have some issues, aren't you? So first of all, let's write out, you straight away write out that we've got x plus yi is equal to z. You don't need to write z is equal to x plus yi, that's fine. But straight away, I want you to do this. X plus yi minus I is equal to 1, like so. And then I want you to combine your real and imaginaries, x plus I, y minus 1, like so. And this is the minimal amount. You don't have to do any more than this. I could then go straight away to x squared plus y minus 1 all squared. Of course, we're squaring both sides, but you can quite comfortably skip that step. Now it says write this rule in Cartesian form. Is that it? Is this Cartesian form? Yeah. Now look, you don't need to do this, but just so we know, you might as well do it. We've got a circle, centre, 0, 1, radius 1. Now you're not going to get any marks for that, but it's probably a fair chance that you're going to need to know that later anyway. Okay, so no harm in writing that. The easiest 2 marks you'll get in your life. Now it says find the points of intersection of this and this in Cartesian form. So just so you know, you have a CAS calculator which you can use. Okay, just remember that there's going to be some method marks for this. Now, as you can see here, we've got the graph of x squared plus y minus 1 all squared is equal to 1. Now, that's your first one. This is this guy over here. And you've also got z minus 1 is equal to 1. Now, what this is, just by looking at that geometrically, you're not asked to show that. That's going to be a circle, centre what? This is going to be a circle, centre, what? 1, 0, isn't it? 1, 0, radius 1. Okay, without even doing any algebra. So in other words, this circle over here is going to be x minus 1 squared plus y squared is equal to 1. Okay, so what we have now then is I would just go ahead and use the CAS. So I would just say CAS, and I can then go ahead and solve for that if you wanted to. Okay, given the fact that we've got both equations equaling 1, we could solve that in our CAS quite comfortably. So now if you do that solving in your CAS, what did you get? You got 0, 0, the origin. Okay, so you go CAS solve. Now it says find the points of intersection. So there could be 1 or 2. In this case, when you solve on the CAS, you should get 0, 0 and 1, 1. Okay, now I'm pretty sure in this, they're probably saying that this is worth the answer mark, both being correct. If they've only got 1 point, it's not correct. Okay, so it's the points, stating both points correct, and I guess showing some method mark there as well. In this case, we've got the equations. Okay, we've got equation 1, we've got equation 2, and we're solving those in a CAS. Okay. So once again, wouldn't take that much. Now what we've got here is we've got to sketch those on here. It's quite an easy thing to do because we've got a circle centre 1, 0, and let's say that's a radius of 1. So centre radius 1 like so. So we've got a circle which sort of goes like so. It doesn't have to be the world's greatest circle. But okay, and then we've got a circle centre 0, 1, and that's going to go up here, sort of thing. And what do we got? There, there, and there. So it's going to look something like that. The important thing is that the centers are right. You don't need to have some perfect circle. But as you can see, those circles intersect at 0, 0 and 1, 1. That needs to be very clear. Okay, easy marks though, isn't it? Sketch and label the graphs. So what we can say is that, of course, this here, it says here, this is z minus I is equal to 1, and this one here is z minus 1 is equal to 1, like so. Nothing else required. Don't need to label the intersections or anything. We've found those before. Now just find the equation of the straight line that passes through the points intersection of graph this and this and this. Explain, express your answer in Cartesian form. So look, you could do a number of things, but what I'm going to say is that z minus I is x plus yi minus I, if you like. And if I was to let those equal x plus yi minus 1, like so, then you probably do this without even a calculator, and that's probably worth 1 mark anyway. Now that's the magnitude, or the square root of x squared plus y minus 1 all squared is equal to, if we're doing it algebraically, but the thing is, is it just 1 mark? It's just 1 mark, so you don't really need to do all this. If you express the answer straight away, but if you needed to work it out, that's also fine as well. X minus 1 squared plus y squared. Let's square both sides. What do we got? We've got x squared plus y squared minus 2y plus 1 is equal to x squared minus 2x plus 1 plus y squared. Those are going to cancel. Those are going to cancel. We've got, those are going to cancel. Oh, look at that. Y is equal to x. And of course, though, really, because it's only worth 1 mark, find the equation, answer in Cartesian form. Y equals x would be all that is required. But I didn't need my calculator for that, did I? If you're doing it, if you're getting it, if it's faster in the calculator, go for it. Okay? Now, it says here, find the straight line found in part DI that can be expressed in this form, z is equal to alpha z bar. Now, the thing is that in complex numbers, there's always going to be in the exam 2 or 3 abstract marks, which that's what separates most of the students. The strong students get the first 7 marks in this case, and then there's 2 marks where it's a little bit out of the ordinary. Okay, so what you need to do is in this, first of all, realise that z is equal to x plus yi, and z bar is equal to x minus yi. And if we write that out, you should be able to see, and logic will actually dictate the rest. So what we're going to do is we're going to go x plus yi is equal to alpha x minus yi, since the conjugate of z is x minus yi. Now, it says here, it says the straight line found in part DI, which is what y is equal to x. Okay, so where do we go to from here? Well, you know what? In actual fact, why don't we just do this? Why don't we just go, we expand that out. If I've got x plus yi, and then I've got alpha x, and then I've got, what's that? We've got minus alpha yi. How does this, what would alpha have to be? What would alpha have to be? Did you try it? Did you try? What did you get? Alpha has to be equal to I. Yeah. Let's explain. So first of all, so if alpha is equal to I, then that means we've got minus I squared y. That's going to be equal to positive y, isn't it? Like so. What about over here though? Is that right? Yep. So there you go. There you go. Therefore, alpha is equal to I. Alpha is equal to I. So as you can see, a lot of that one, it's not as obvious. You need to sort of think it through. Now, for the time being, I'm just going to stop that there because I don't think this is still going. 10 minutes. Look, we've explained it in 10 minutes. So I reckon that 9 marks, you could be aiming for maybe to do it in about nine minutes, but that means that you're going to spend longer and some of these other questions. And look, whilst we're doing that, as you can see, as we go down across here, what you actually notice is quite a few of these exam questions are actually starting to repeat themselves. Look at this. We're looking at another question from exam 2. Once again, verifying a point from the line by subbing it in, using the or finding the Cartesian equation. In this case, we needed to do a bit of algebra. Okay, so you can see there that once again, very similar sort of questions. And then, of course, we're sketching over here. We're sketching a line and a circle on an REM diagram. We're not going to find that area because that's a region. But a lot of these, when you go through these questions, a lot of them has become very similar. You notice here, you can see that these questions are very similar. There's about 4 different cases of these. You've got the perpendicular bisector. You've got circles. You've got the real of Z. You've got the imaginary of Z. And then you've got the arguments of Z. So if you make sure that those are in your bound reference, and also take note that any of these regions which are involved inequalities, we do not need to do those because they have been removed from the course. Okay? That being said, though, there are some questions which are still in the course which you may think are not in the course anymore. Those ones, regions, not doing. However, there are some questions, and there has been in the last couple of years of exams, where we actually do need to do those questions. Things such as this. Can you see there? Let's just automatically go to this question. What type of question is this? Or what type of, when we're sketching this on the complex plane, what is it? This is what? Starting with P. The perpendicular bisector. So that is going to be a line. You need to be able to recognise straight away that's going to be a line. And of course, you can do it by doing the algebra like we've done in today's class. But if you can recognise that that's a line, that's the perpendicular bisector, and basically we're looking at they're equidistant from the point U and the point minus U, then that's going to save you a lot of time and get you a lot of guaranteed marks in the exam. All right, so I'm going to stop that there. I hope that's given you at least an introduction that you can watch in October when you forget a lot of this stuff. So I'm going to hit stop now.